All right, so here we got another sum formula for geometric sequences. So we know it's kind of geometric if it looks like an exponential function. So you can see it's a sub 1 times 1 minus r to the power of n over 1 minus r, okay? Okay, so you can kind of just, if you're familiar with the formula, the kind of a sub n equals a1 times r to the power of n minus 1, you can kind of get all of this information from there. So we know that in this case, a1 is 3, and we know r is 4. And then n is, if you're starting with 1 on the bottom, n is just the top number. If not, you're doing top minus bottom plus 1. Okay. Now, when you're typing this in the calculator, I would just do the top and the bottom first. So we know that the bottom is negative 3. The top, 1 minus 4 to the power of 13 would actually be, well, it's a huge number. Man. So negative 671088863 goes there. Okay, so I'll divide that by negative 3 and then multiply it by 3. So really, since those cancel out, it's just going to be the positive version of this number as my answer. All right, so same idea here. So we'll say sum equals 81 times 1 minus, let's see, r here would be 1/3, which since I'm going to raise that to an exponent, I'm going to put it in parentheses, and 1 minus 1/3 on bottom. Okay, so this is going to be 81 times 0.99954 over, let's see, 0.6667. And so that sum comes out to about 121.4, let's call it. All right, and then lastly here, number 7. So this one is going to be sum equals a sub 1 is 1, and then 1 minus 3 to the power of 5 over 1 minus 3. So obviously that 1 is kind of irrelevant here, so I'll leave it off. 1 minus 3 to the power of 5 would be negative 242. Divided by negative 2 is 121. Okay, next up here it says a company plans to increase production of a product by 10% each year over the next 12 years. The company will produce 70,000 units next year, which we're going to call year 1. So I know a sub 1 is 70,000. And then my r here is a little tricky. It's based on the 10%, but it says increase by 10%. So I have to, whenever it's an increase or a decrease of a percentage, I always have to add or subtract that from 1. So I'm going to take that 10%, which is 0.1, and add it to 1, so that'll be 1.1. If I put 0.1 there, it would actually be getting smaller, so that's why I need to add the 1 there. So then a sub n equals 70,000 times 1.1 to the power of n minus 1. I'm using the n minus 1 version of the formula since it defines this as year 1. Okay, so it's asking us now to find a sub 4. So a sub 4, I would just plug in 4 for n. So I'm just going to do that on the calculator. So 70,000 times 1.1 to the power of 3. And so that's 93170. A sub 8, I'm just going to change that now to the power of 7 since it's n minus 1 power. And so that's 136,410. And I would actually stop at there. I would not put a decimal since it's number of units. So you can't really make like 0.1 or 0.2 of a unit. And then for a sub 12, I would just plug an 11 into the exponent. And so that is 199718. All right, and then the total number of units produced over the next 12 years combined. So that's my sum formula. So I know my a sub 1 is 70,000. 1 minus r to the power of n over 1 minus r. So I know the denominator there is negative 0.1. I'll go ahead and figure out what's 1 minus 1.1. to the power of 12. So that's negative 2.1384. Divide that by negative 0.1 times 70,000. And I get 149,689.9. Once again, I'll round that down since it's like we didn't get to that next unit. Even though it's a 0.8 here, it's like I didn't get to that next unit. All right, next up here, we're actually going to look at infinite sums. So on geometric sequences and series, we can actually find the sum of an infinite number of numbers, which is kind of crazy if you think about it. Only in some cases, though, provided that the absolute value of r is less than 1. And so I'll kind of interpret that like this. I'm going to put -1 here and then 1 there with open circles. And so we are saying that r, in order to use this formula, has to be in between -1 and 1. So if r is kind of outside of those numbers, okay, then the series has no sum and is said to diverge. So if it's out here or out here, we cannot use this formula. Okay. Okay. So here's the formula: S equals a sub 1 over 1 minus r. And so we're going to do sum equals, and I kind of know here that the first term is 6, and then the r is 0.6. Just kind of based on my a sub n equals a1 times r to the n minus 1 formula. And so it's going to be 6 over 0.4. And so that's 15. Okay, so same idea with my next one here. So the sum equals 9 over 1 minus 5 over 6. I'm actually going to do this one by hand, so I'm going to call this 6 over 6. So that'll be 1 over 6, 9 over 1 over 1 over 6. So we'll multiply by the reciprocal there, times 6 over 1. And so that one comes out to 54. All right, for this one, I know that a1 is 1, but for r, I would have to do -2/3 divided by 1. And so obviously that's -2/3. So 1 minus a -2/3. Now, I'm going to do this one by hand as well. So we're going to call this 3 over 3. And we have minus and negative on bottom here. We'd have to add them. So we would get 5 over 3 on bottom, 1 over 1 on top. Multiply by the reciprocal there, 3 over 5. And you're just going to get 3 over 5 for your sum. All right. Does it make sense that that answer is positive? I would say yes. We're adding up like an infinite number of a positive number and then a negative number that's a little bit smaller. So the answer will come out positive. All right, number 2 here, if I figure out what r is -2 divided by 1, which is -2, and I'm going to right away say no sum, and I'm going to say it diverges. And so we said kind of the rules on this were, and if you look back at all of these r's here, we have 0.6, we have 5 over 6, and we have -2/3. All of those are in between -1 and 1. This one is not, and so we cannot find the sum. All right, so next up, we can use this kind of pattern here, or we can use this formula to write repeating decimals as fractions. What you want to do is you want to kind of write down each little piece as its own fraction. So this one will obviously be 1 over 1 plus, and then the next one will be, this one will be 1 over 10, just because that's the 10th place, okay? And then we're going to have 6 over 100, since that's the 100th place. And then 6 over 1,000, since that's the 1,000th place, and then 6 over 10,000, etc. Okay? So I see that right here is actually our infinite sum here. If you kind of look at here, I would have to multiply by 1 over 10 to go forward. So I would say that that's my r. And so I can do my infinite sum here as a1 over 1 minus r. Okay, and so I know this is 10 over 10. Okay, so that's going to make 9 over 10, 6 over 100. Multiply by the reciprocal there. It's 10 over 9. We can cross cancel here. That's going to be 10, and that's going to be a 3, and that'll be a 2. We can actually cross cancel these more, so that'd be a 1 and that'd be a 5. So this is going to be 1 over 15. Okay, so all that came out to, so this is actually 1 over 10, sorry, 1 over 1 plus 1 over 10 plus 1 over 15. So I'll just add all those together with a common denominator, so I'll make them all 30. So it's going to be 35 over 30, which actually reduces to 7 over 6. So 7 over 6, if you type that in the calculator, should give you that 1.16 repeating. Okay, so same idea here. So I'm going to say 4 over 1 plus, and then these ones I need to group together in groups of 2, so it's going to be 72 over 100. And then we have 72 over, and since I skipped one there, it's going to be over 10,000 now. All right, so then this one, it's times 1 over 100 here is my r. So if I find my infinite sum here, it's going to be a1 over 1 minus r. So this is obviously 100 over 100, so 99 over 100, multiplied by the reciprocal there. Cross cancel. Actually cross cancel a 9 here, gives me 8 over 11. So it's 4 over 1 plus 8 over 11. Do a common denominator here, 44 over 11 plus 8 over 11. And that gives me 52 over 11. And double check that on the calculator. And yep, that's it.